In today's note, we're going to be looking at determining the slope and rate of change. Now, we've touched on slope and rate of change before when we were dealing with the distance time graphs, most specifically when we were determining the speed. So this is going to be basically the same thing, except we're going to be looking at this for any straight line regardless of what the variables are. So as a quick recall, the equation for a straight line is y equals mx plus b, where the slope is m, and our y-intercept is b. Now, some other terms that we've talked about: slope is also known as the multiplier, and or also the rate of change, and our b is also known as the constant. So those are just some other terms that we've talked about that you may see come up. So in our example, as a review, given that the straight line has an equation 3y minus x equals 15, we want to determine the slope, y-intercept, and x-intercept for this given line. So if I have this equation, 3y minus x equals 15, I can't get any information out of this until I convert it to y equals mx plus b. So in order to do that, I have to rearrange it. So I'm going to move over the x first. So when I move over minus x, it becomes plus x, or I don't need to show the plus, I can just put x, and then plus 15. To get rid of this 3 in front of the y, I need to divide both sides by 3. So I get y equals x divided by 3 plus 15 divided by 3, which would be 5. So that is my equation now. Now, if I want to determine my slope, I need to look for my m value, or what is that value that is being multiplied by the x. Well, in this case, it is 1 over 3, because 1 over 3 times x is just x over 3. For my y-intercept, it is the second value. So my y-intercept, my constant, is 5, or as a point, 0, 5. And now I want to find my x-intercept. And while I can't get that from the equation, if we remember, our x-intercept, it'll have an x value, and the y value will always be 0. So using this, I can take my equation, y equals x over 3 plus 5, substitute that 0 in for y, and solve for x. So 0 equals x over 3 plus 5. I want to get the x by itself, so I'm going to move the 5 over. It becomes minus 5 equals x over 3. And to get rid of this fraction, I'm going to multiply both sides by 3. So I get negative 15 equals x, which can go back into my point. So that means my x-intercept is negative 15, or the point negative 15, 0. So as we're moving on, we're looking at slope and rate of change. Now these are both the same term, or two different terms regarding the same thing. Rate of change talks about the increase or decrease in the y value in relation to the x value, or in other words, the first differences, which we have talked about in our scatter plot unit. So looking at the table of values shown represent a line. And then as the x values increase by 1, we go from 1, 2, 3, 4, 5, 6, the y values increase by 2. So we can see that by finding the first differences, or you can visually see that. You can do that off the top of your head. From 4 to 6, it's an increase of 2. From 6 to 8, 8 to 10, 10 to 12, 12 to 14. If you weren't sure, you can find the first differences. So that means that the rate of change of this line is 2. So in our first example, I want to determine the rate of change for the following table of values. If we look at our x values, they're always increasing by 1. And to look at my y values, if you can't tell just by looking at them, you can do the first differences. So that means bottom minus the top. 5 minus 1 equals 4. Next one, 9 minus 5 equals 4. 13 minus 9 equals 4. And we can see a general pattern happening. So that means that my rate of change is equal to 4. For example B, same thing. My x values are always increasing by 1. And for my y values, if you can't tell by looking at it, you can find the first differences. So negative 1 minus negative 4 equals 3. 2 minus negative 1 equals 3. The next one, 5 minus 2 equals 3. And again, we can see the pattern now where the first differences are all the same and they're 3. So this means that our rate of change is equal to 3. So that's finding the rate of change using the table of values. Slope is another term for rate of change, and when we've talked about slope, we've talked about it as a measure of the steepness of the line. So we've talked about this when finding speed, and we found that it could be positive, negative, 0, and new to this note is undefined. So that is a new term that we're going to be looking at in this note. And remember, when we looked at distance time graphs, the steepness or the slope told us the speed. And if we remember, speed is equal to distance over time. So given this distance time graph, let's try to determine what the speed is, or the slope, for each line or each section. So if I look at AB, from A to B, I need to know my distance. So in this case, I start at 0 and I travel to 3. So that means it's a distance traveled of 3 kilometers. And for time, it took me from 0 hours to 5 hours. So that means 3 kilometers in 5 hours. So 3 divided by 5. So that gives me a steepness or a slope of 0.6 kilometers per hour. For BC, this straight line here, we already know that a flat line means a 0 speed, and it's the same thing for slope. So in this case, my speed, my distance traveled is 0 because I haven't traveled anything. I've stayed at 3 kilometers. My time is 3 hours. 0 divided by 3 is 0 kilometers per hour. So that means that the steepness of that flat line is 0. For CD, again, same formula. Where do I start? I start at 3 kilometers and I travel to 12. So that's a distance traveled of 9 kilometers. How long did it take me? Well, I started at 8 hours and I went to 12 hours. So that's a total time of 4 hours. So 9 divided by 4 gives me a speed or a steepness of 2.25 kilometers per hour. For D to E, again, distance traveled, because it's a flat line, my distance traveled is 0. And the time that it took, I went from 12 hours to 14 hours. So that's a total time of 2 hours. So that means my speed is, or my steepness is 0 kilometers per hour, or 0, which again we know from it being a flat line. And on the return part, or the next section, E to F, I start at 12 and I end up at 0. So that means my distance traveled is negative 12 kilometers. And if I started at 14 hours and ended at 20, that's a total of 6 hours. So that means my speed for section EF, or the slope or the steepness, is negative 2 kilometers per hour. And again, we talked about the negative not referring to the speed, but more for the direction. But in this case, our slope or steepness or speed is negative 2 kilometers per hour. So to calculate the steepness, speed, or slope, we looked at, again, speed is equal to distance over time. But we've talked about at the beginning of the note, we're going to be generalizing this for any straight line or any linear graph that's not always going to be dealing with distance and time. So how can we generalize what we just did? And what we can generalize that as is the idea that slope is equal to rise over run. Or you can talk about, if the top part was distance and distance was vertical, the rise talks about the change in y, and the run, or the horizontal, talks about the change in x. So rise talks about the vertical distance between 2 points. Run talks about the horizontal distance between 2 points. Or basically, what are we changing in our y values compared to what we're changing in our x values. So if I look at my next example, if I want to find the slope, I know it's equal to rise over run. So what I want to do is find out, where does my graph start at and where does it end? And we're going to look at it in two sections. One is the vertical. So vertically, how much do I change? So if I'm going up from this point, from A, if I start at, and it looks like that is 3.5. So 3.5, and I go up to 6.5, that means it's a vertical change or vertical distance of 3. So that means that my slope so far is going to have a rise of 3. For my run, if I'm starting at, looks like 1, and I'm going over to the next point, follow it down and going to 7. So if I go from 1 to 7, that's a change of 6, or an increase of 6. So that means my run is going to be 6. So overall my slope is a rise of 3 and a run of 6, which means that overall it would be 1 over 2, or 0.5. So that means my slope of this line is 0.5, or 1 over 2. I would suggest leaving it as a fraction, because this way you can tell how much you're going up by versus how much you're going over by. So in example 2, what we want to do is go through and find the slope of the following line segments. So here would be a good place to pause and try this on your own. And when you're done, you can come and check your answers. So moving ahead, if I want to look at AB, I start here and end here. Again, slope is equal to rise over run, which will be equal to, if I start at 2 and I go up to 7, so that's a rise of 5 over, and if I start at 0 and I go over 1, 2, 3, it's a run of 3. So my slope is 5 over 3. For CD, if I start at C and go to D, again, slope is equal to rise over run. So for C, if I start at 1 and I end up going down 1, 2, 3, 4, 5, 6, I go down 6, so that means I have to use a negative 6. And my run, if I start at 1 and I go 1, 2, it's an increase of 2. So my slope is negative 6 over 2, and I can simplify this to negative 3. For EF, EF is an easy one because it is a flat line. We know about from distance time graphs, a flat line means it has a slope or a speed of 0. So if I want to still figure this out, my rise is 0. I'm not going up anything from E to F. And my run, I'm increasing by 1, 2, 3. So I'm increasing by 3. So I end up with 0 divided by 3, which is 0. For G to H is different. We haven't seen a straight vertical line before. But again, we can still use the same idea. Slope equals rise over run, which is equal to, if I go from G to H, I start at 5 and I go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I go down 10 or negative 10, and my run is 0. I haven't moved horizontally at all, so it is negative 10 divided by 0. And if you try this on your calculator, you should get something that says error or undefined, and that is fine. That is what you want to find in this case. Lastly, for I to J, again, same idea. Slope is equal to rise over run. So vertically, if I'm rising, I'm going up 1, 2 to my next point. So I'm going up 2. And the run, I'm going over 1, 2, 3, 4. I'm going over 4. So that means that my rise over run is 2 over 4, or it can be simplified to 1 over 2. So that is finding the slope for all of these lines. And again, we can see the different types. We have one of each type: positive, negative, 0, and the new one, undefined, which is a vertical line. In example 3, now what we want to do is, if we have a line segment where we have one endpoint at negative 2, 1, and we know what the slope is, we want to find the coordinates of other endpoints. So, let's plot this one point A of negative 2, 1. So again, negative 2 is x, 1 is y. So if I go over to negative 2, then up to 1, there's my point A. Now, how do I figure out where the other points are going to be? Well, if I know my slope, which is equal to rise over run, is also equal to negative 3 over 2, I can use that to plot my other points. What that means is, based on this point, if I follow my slope, which means from here I have to go down 3, so 1, 2, so that's 1, 2, 3, and then go over 2 in the positive direction, 1, 2, that gives me my new next point, which is 0, negative 2. Now, we talked about there being two possible answers, and what this means is that I can go in the other direction. So that means I would be going backwards. So that means I would be going to the left 2, so 1, 2, and I'd be going up 3. So 1, 2, 3, which gives me another possible point of negative 4, 4. So this is where you can have two possible answers depending on how you want to determine the slope. And because if we look back at our question, the negative is out front. And when we talked about negative fractions, we talked about how if the whole thing is negative, that means either the top number is negative or the bottom number is negative. So that means that negative 3 over 2 is the same thing as being written like negative 3 over 2 or 3 over negative 2. So that's where we get going in both directions for either point. In example 4, same idea. Let's plot our first point, the A value, where we have A is 6 and negative 2. So this is A, and now I want to find other endpoints. So again, there are two possible answers, so that means that from this fraction, my slope, which is equal to rise over run, is also equal to negative 3 over 4 or 3 over negative 4. So that gives me two directions I can go in. So in this case, let's go down 3 over 4 first. So if I start at -2, I need to go down 3. So 1, 2, 3, and over 4. So 1, 2, 3, 4, which gives me my next point, which is 10, -5. And if I want to go in the other direction, I'm going to go up 3. So 1, 2, 3, and to the left 4. So 1, 2, 3, 4, to a point of 2, 1. So those are the two different endpoints that I could have. So the key thing from this note is understanding that for any given straight line, we can find the slope, the rate of change, or the steepness by doing rise over run. And rise over run is just the change in the y values over the change in the x values.